And just a continuation of lesson 6.7. So this video will talk about how to write a polynomial function of least degree that has the given zeros. So we've been working with polynomial equations and finding the solutions or finding the zeros of them. So in this type of problem, they're going to give you the zeros and ask you to find the equation or the function that would have those solutions. So working backwards a little bit here, if your zeros, so if I say write a polynomial function that has the following zeros, if positive 2 is a 0, that means that x minus 2 is a factor. And if negative 1 is a 0, x plus 1 would be a 0. And if negative 3 is a solution, then x plus 3 would be 1. So then, this must equal 0. We're just going to multiply all this together. I'm going to want to do this using maybe 2 factors at a time. So these first two I could FOIL. I'd have x squared plus 1x minus 2x minus 2. And if I combine like terms there, I'd have x squared minus x minus 2. And then I've taken care of these 2 factors. Now I've got to get the x plus 3 involved. And I would multiply all this together. So I'd run the x squared through. I'd have x to the third. I'd have a negative x squared. I'd have a negative 2x. And then multiplying it through by the 3, I'd have 3x squared, which I'm going to put right there. I'd have a negative 3x. And I'd have a negative 6. Combining like terms, then, I'd have x cubed plus 2x squared minus 5x minus 6. And that would be the third degree equation that would have those 3 values as its solutions. Now, we have been talking about when you could potentially have an imaginary solution. So if you've got 2 plus I, we have something that's called the complex conjugate theorem. The complex conjugate theorem. And hopefully you noticed earlier that if you have imaginary zeros, they will always come in pairs. Always come in pairs. So if you have, let's say 2 plus I is a 0, then you must have 2 minus I as another 0. It's conjugate, changing the I part. So now, if 2 plus I is a solution or a root, then x minus 2 minus I would be a factor. And then we're going to do this one. And I'd have x minus 2 plus I. So I'm just taking the opposite of those, what makes it equal 0. And then I would need to distribute. So I'd have x squared. I'd have a negative 2x. I'd have an xi or an ix. When I run the negative 2 through, I'd have negative 2x. I'm going to keep those together. I'd have positive 4. I'd have a negative 2i. Keeping like terms together. And then I'd have a negative ix, which is going to go right here. A positive 2i, and then a negative I squared, which if you remember, I squared is a negative 1, so a negative I squared is like a positive 1. Now what will always happen is any of the terms that involve I will just cancel out. So these are going to cancel, these will cancel. You're left with x squared minus 4x plus 5. So that dealt with the 2i and the 2 minus I. I've got to get the 3 involved. So I'm going to take this times x minus 3. And now again I'm going to multiply. Run the x squared through, or run this all the way through the x. Either way is fine. I have a negative 3x squared. I'd have a positive 12x. And I would have a negative 15. I would then combine like terms. And I would end up with this cubic equation. That would have those given zeros. So the ones with I, remember those i's are going to cancel. So in this last example, now I've got 2i, which means I got to have negative 2i. That's that complex conjugates theorem. I've got root 5 and negative root 5. So my factors would be x plus 2i, x minus 2i. I'd have x minus root 5, and I'd have x plus root 5. And then I'm going to multiply these together, so I'm going to get x squared. I'd have a negative 2ix and a positive 2ix. I'd have a negative 4i squared, which remember is the same as a positive 4. Those I terms, kind of a common theme here, will cancel. So those two give me basically x squared plus 4. Now I could take these two and multiply them together. So I'd have x squared. I'm going to have root 5x and negative root 5x. And then negative root 5 times root 5 would be a negative root 25, which is just plain old 5. These cancel, and I'm left with x squared plus 5. So I did 2 at a time. Now I'm going to multiply these together. So I'd have x to the 4th plus 5x squared plus 4x squared plus 20. I got like terms. I'd have x to the 4th plus 9x squared plus 20. That would be the 4th degree equation that would have these 4 zeros. So that's how to write a polynomial equation given zeros.